The following is an original production of AZPM News.
For Arizona Public Media, I'm Erika Hamden, professor of astrophysics at the University of Arizona, and this is Arizona Science. Joining me today is Derek Lemoine, professor of economics at the University of Arizona and co-director of the Consortium for Environmentally Resilient Business. Derek's research explores the intersection of climate change and economics, including a recent paper that discussed how improved weather forecasts can help to reduce mortality as the climate warms. Welcome, Derek.
Thank you for having me, and thank you for doing this. It's a great service.
You recently had this paper come out that talked in particular about the link between improved weather forecasting and how to mitigate deaths from extreme heat.
Sure. There's a couple steps in the paper, so I think we'll unpack it sort of one by one. So the first is just what do weather forecasts do for avoiding mortality from extreme temperature? So temperatures kill people in two ways. One is extreme cold kills people. The other is extreme heat kills people. If you remember from COVID, there's a lot of discussion of excess deaths, and the idea is roughly the same, where it's not that cold is marked in your death certificate. It's that you're statistically looking at days with different temperatures, and you're seeing how many more deaths were there above what you may have expected for a day in that time of year and in that location.
If that day had just had like an average temperature.
Exactly. It's exactly what you're doing. So you're comparing within a given location over time. You're saying a day that happened to have an unusually hot or cold temperature for that time of year. How did deaths compare to a day with an average temperature for that time of year? And the takeaway from, there's a mountain of papers that do the pure death temperature side of it. By and large, is that heat kills pretty quickly. A lot of those are deaths that would have kind of occurred anyway over the next 2 weeks. It's people who are maybe on sensitive, elderly, sickly, and they die sooner than they might have otherwise died.
Okay.
And cold tends to kill not immediately, but over time. The deaths from cold compound over time, whereas the deaths from a single hot day are sort of, in a sense, borrowing from the near future. So they kind of get mitigated the longer out you look.
Okay.
What we're looking at here is how do weather forecasts affect that. So we're comparing days with the same temperature, that some of which happen to have an accurate forecast and some of which happen to have an inaccurate forecast. And we're here studying 1 day ahead weather forecasts. Okay. So we might think of those forecasts as perfect, but it turns out they're not. They've been getting better over time. They're about 35% or so better than they were back in 2004, 2005. And what's really impressive is that even for as good as they are, we can see in the data that days with more accurate forecasts have less mortality, and days where the forecast turned out to be inaccurate after the fact have more mortality. If it's a hot day, if the forecast turned out to be too hot after the fact, you don't see more mortality. But if the forecast was too cool on a hot day,
people weren't really prepared for the actual reality.
That's the interpretation, because we're looking at days with the same temperature. So the weather you experience outdoors is the exact same. So the only reason why deaths could depend on the forecast is that people used the forecast to do something, and they did the wrong thing when the forecast was too cool, and they were prepared properly when the forecast was too hot.
That's really interesting because it says to me that like a lot of these extreme heat deaths can be avoided with the correct planning.
Correct. And it's not that the government has to help us plan. It's that we just need the right information to be able to make the best plans we can. And weather forecasts are purely just a form of information. And people use that information and they're making choices, trading off health risk against other things. They need to get stuff done.
I'm curious about where the improved forecasting actually has come from. Is it like better satellites that give us better data, better modeling, all of the above? And do you think there's a way to get improved forecasts on that like 1 to 3 degree level?
Right. So why forecasts have been getting better? Part of it's improved numerical weather predictions, so improved modeling of the climate and the weather system. And like there's big supercomputers the Weather Service is using to model the weather and the climate every day. And I mean, really, in this case, we're talking about weather. It's like, what's the weather going to be in a few days? And so they're literally simulating weather across a grid of the whole globe, a 3-dimensional grid. And to do that, you both need to have the computers that are big enough and the algorithms that are chewing the data and solving the equations in the best possible way. So those have all gotten better over time. But also you need the data inputs to that model to be good, because you have to know what the temperature is at all different points in the ocean, both
like
at the
right
surface
now.
and right now, hour by hour right now, and both at the surface and deeper, and in the lower atmosphere and in the upper atmosphere, and in locations like the U.S. where we have lots of weather stations, and in locations like Africa where you have fewer weather stations. And so all this goes into calibrating the model to what's the world like at this second, to then run the world forward another day or a week, whatever you're interested in. And so part of it is definitely that the algorithms and the computers have gotten better, and part of it is that the data inputs have gotten better. We've got more ocean buoys, we've got more satellites in space, we've got just more weather stations on the ground. So all these inputs are getting better. So what we're doing is we're running a survey of a bunch of professional meteorologists and weather forecasters throughout the United States, and we're asking for their beliefs about how good weather forecasts might get in the future. And we're trying to bound, like, this is a really fast improvement scenario, this is sort of a central improvement, this is a very slowed improvement scenario. And we do ask them, how would you get to the better scenario versus the worst one? And for them, it really comes down to better models, to more investment in computation, more investment in data, which partly means satellites, partly means like ocean buoys and things like that, weather balloons, and staffing. So staffing is a big part to them. And what's really interesting is that for them, when you ask them a separate question of how can you best serve the public, what do you need to do, staffing is the number one thing. Because a lot of what the Weather Service does now is actually translate a numerical forecast into action by working with emergency personnel and working with city managers and communicating it through radio and through TV.
Yeah, and letting people know what is potentially going to happen.
Absolutely. And that's a really essential part. And so that's all kind of baked into our estimate, the extent to which they're doing that well. And we can't separate out how much of, we're not looking at improvements and we're not looking at changes in the response to forecast over time. But presumably if you did that, you would see a mixture of people trusting forecasts more and us getting better at communicating.
You had a paper in 2025 that talks about how the effects of climate change have already made us poorer. And so I'm curious about like what you found in that paper and kind of what are the implications in the long term.
So economists have been interested in the damages from climate change, and in particular projecting the damages from future climate change. And we care about that both because knowing what those are help people adapt today. And the weather forecast conversation we have was about ways of helping people adapt. The other reason economists care about projecting those damages is that if we want to think about how quickly we should cut emissions today, the value of those emission reductions is based on the avoided damages from climate change. That's a very hard thing to do. And I've just published a review paper about what we know about that. And one of the conclusions is like we're never going to be able to do that perfectly. The question here was, well, to get that number, we should at least be able to say what climate change is already doing to the economy, taking out the whole projection side of it. And so when you write down a model of what that looks like, it turns out you need to know three things. You need to know how climate change has altered the weather today where you live, how it has altered weather in the past where you live, because you have made decisions in the past that you've made investments in, let's just say, irrigation or air conditioning that then affect your exposure to weather today. And then you also need to know how it affects weather everywhere else around the country, both today and in the past, because everywhere else in the country is linked to you through prices and through trade. And that's an important part of climate change.
So in terms of someone like listening to this, thinking about their own income, does that mean that they would be making potentially 12% more, or that their like life would be?
This is an average effect on U.S. income per capita. So you can't say like some people are doing better than that and some people are doing worse. And so on average, it would net out to that across the country. You could say the country's income would be that much higher. But also, I think the main message for somebody listening is that the most obvious impacts from climate change to us are just the way the weather outside where we live right now affects us. And what this is showing is that, and that's what economists have typically focused on, and what this is showing is that that's actually the kind of the smaller part of the equation. It's the fact that it's affecting the weather everywhere, that's a change in large-scale weather patterns. So take an example of a farmer growing corn in Iowa. So imagine that there's, let's just say that there's 50 counties in Iowa, and then your county gets extreme heat and your corn yields go down. That's not good for you. You're going to have less revenue. But if nobody else's corn gets hit, corn prices don't really change. You're a drop in the bucket. But if the whole Midwest and all of Iowa is hot at one time and everybody's yields go down, then the price of corn changes and it's going to have to go up in order to balance supply and demand. This actually might be good for you as a farmer. You get to sell less.
Even though you had less, you're still making money.
And I do see that. Like I can't get at that level, but I can see in more agricultural areas that the local heat channel is negative, but the widespread heat, if everybody else is hot, that's positive. That actually increases your income. But for the rest of the U.S., everybody buying corn, and not just people buying corn directly to eat, but people buying it all the way throughout the supply chain as feedstock for livestock, as inputs into plastics or ethanol or anything else we use corn for, that's going to ripple through the rest of the economy. And that's the main channel. And that's not something where you're going to walk out and say, oh, corn's cost this much. Clearly, this 20 cents are because everywhere else in the country was hot. Like, it's not going to be as immediately salient to people walking in the store. It was somewhat surprising to me that economists had never turned the telescope around to think about these current losses. I mean, there have been a couple of papers in the margins, but it's just not been the central focus of study in the same way that future damages have been.
Yeah.
And a lot of that is because if you go back 20 years when economists first started really getting into climate change, like let's say the 90s to 2000s, climate change was seen as really a thing for the future at that point. And the projections for it absolutely matter. There will be more climate change in the future. Losses would presumably probably grow greater than what they have been. The future is what we can actually control and do things about. But there is still value in understanding what's happening now because it does inform the kind of decisions people might make to adapt to climate change. It tells us, for instance, in this case, a lot of the adaptation isn't you having air conditioning in your own house. It's more social security, like social safety net type adaptation, because it's prices on the whole that are going up. It's not just protecting people from the direct weather outside.
It's not just like a physical how are you feeling in the weather. It's actually like the whole economy.
That's right. Yeah, the whole economy. We live in a pretty tightly linked country where, I mean, there's basically, essentially, ideally, very few trade barriers across states. And so one thing that happens in climate change is something that happens to every state at once, and those things spill over across states. And it's not something but one county can just wall itself off.
Yeah. And I think also people think in terms of the economic cost of climate change more as in like catastrophic events or like flooding or hurricanes. And so this, I think, is also valuable that it comes in these other ways.
These small shifts in daily temperature, they really can add up to pretty significant numbers. And it's not clear to me that they're not more important economically than the big events that capture attention.
Well, thank you for talking with us, Derek. It'll be really exciting to see how your work continues to develop and hopefully makes people's lives better in a really material way.
That's what we all hope for. So really, thank you for having me. Thank you.
This is Erika Hamden, and you've been listening to Arizona Science. We've been talking with Derek Lemoine, who works on how climate change will impact our lives, both economically and in other ways. You can hear more of this conversation and others on our Arizona Science segments by going to azpm.org.
This has been an original production of AZPM News.